Hello, welcome back to Creating Creative Chaos. And this week, I'd actually like to talk a little bit about something that doesn't get a lot of attention, I think, in science fiction uh, writing and in television and movies. And that's actually how the inside of a spaceship looks, specifically a realistic one. Um, I mean, there's a lot of things to consider here. I mean, because there's a lot of attention that's been given to how spaceships actually move through space through various types of engines, faster than light drives, et cetera, but not necessarily a lot of thought and attention to how the actual crew moves around inside the spaceship, which I think is actually uh, probably equally important in a lot of ways, and definitely is one of those things that if you spend a little bit of time thinking about, you can make a lot more, add a lot of depth and quote unquote realism to your story. So let's think a little bit about how they're portrayed right now. If you look at a lot of TV shows, I mean, when you're looking at, say, for example, spaceship corridors, you tend to get like a something that wouldn't look out of place on just any sort of building on Earth. I mean, they tend to be rectangular. You've got carpet on the floor, uh, doors that slide open, et cetera, et cetera. And there's a really solid reason for that, and that tends to be comes down to budget. If you want to simulate zero G effects in a movie or a TV show, I mean, that's going to cost money. You got to have wires, maybe CGI, however you want to do it. Um, And if you actually want to build a set that's based in a zero G environment, that's going to cost more money than just say slapping together a standard plywood, normal looking corridor with carpet on the floor. So that's the main reason that I think that there's, especially when you look at hallways, they tend to be ones that could easily be translated into a normal building on Earth. Um, but that's not to say that there hasn't been an attempts to do this. The Expanse, for example, does a good job of trying to incorporate zero G or low gravity into their setting, and designing sets around it. I mean, heck, you could go all the way back to 2001: Space Odyssey if you want to see a really good attempt to simulate a low gravity environment and how that would play out actually in the interior design of a space station or ship. But let's say you want to take your own take on it. You want to create a realistic near future science fiction setting and environment. And one of the things I would strongly encourage you to take a look at, spend some time on, is actually how the interior of a ship would be laid out, or the interior of a space station would be laid out. And there's a couple of things to think about. The most obvious one is going to be gravity. Um, if you're in a setting where, if there's artificial gravity available, I mean, I would say that's probably not going to be realistic, at least in the near term. But if you've got, like, say, spin gravity, for example, this is again something that 2001 Space Odyssey does a good idea or a good job of simulating. Um, Keep in mind that your carpeting or the floor, for lack of a better term, is going to be on the exterior of whatever's spinning. So if you've got any sort of, and it's going to most likely be in a circle, a circular configuration or however you want to do it. Uh, but just keep that in mind. That's actually fairly obvious, I think. Um, in a zero gravity setting, which I think is probably going to be a little more realistic for a spaceship in a lot of ways, um, consider why you would need carpeting anywhere or anything like that. Or if you're going to have any of those sorts of, quote unquote floor features, that's not necessarily going to be only on one side of the corridor. Because if you're in zero G, you know, why are you going to, waste the time and the mass and the construction by just putting carpet on one side of your hallway when, literally you don't really need it there because everybody's floating in the middle. So that's something to consider. The other thing to consider if you're in a zero G environment is why you would need to have all your control consoles and all the equipment mounted on one side of the core, the down, for example. If you're in a zero G environment, is there a down? Could you realistically have control consoles scattered on each wall irregularly? Might that be a more efficient way use of space? Um, and then, if you think about it, there might be some sort of, the reason that you might want to do that is there's like a psychological human reason to need down and up or whatever. But maybe that's something that can be overcome if if somebody's used to living and working in space, they wouldn't necessarily need that down and up orientation that we take for granted. So if you're describing the interior of your ship, consider, not having, for example, a down in a corridor or in a room or something like that, and maybe describe how that would change how the interior design of your station or ship. And then again, like we mentioned before, and we've done, I think there's science fiction's done a pretty good job of this, is like how, if you have spin gravity, for example, how that would look. Um, and I think again, the one that always springs to mind, if you want to take a look at it, is just take a look at the Discovery in 2001 Space Odyssey. There's a few good scenes in there about what a spin gravity environment might look like. There are things mounted on the quote unquote ground, but there are also things that are mounted, perhaps where they wouldn't be in a more heavy gravity environment, like say on Earth. So that's one consideration. The other consideration, and I think this is something that tends to get overlooked not as much, but the actual configuration of the corridors and the interior of a ship itself. Um, it is a lot easier to pressurize a cylinder than it is a rectangle. The reason for that is that there's fewer points of weakness. This is why, say for example, the International Space Station, when you look at it, you don't see a bunch of rectangles up there. You tend to see cylinders because they're easier to pressurize. And also because we're sending stuff up on rockets, I think it's a lot more space efficient to make them cylindrical as well. So that might also be a factor. Um, and again, I think this tends to be something that if you do see rectangular hallways in, say, for example, TV or movies, that's again, I think probably for budgetary reasons. But if you're writing a story, you shouldn't have those. So consider making everything round. Not a lot of straight edges. Um, I mean, I guess you could if you had like the entire shape spaceship was a giant cylinder, and then you could put square hallways in there. But honestly, I think that aesthetic is something that we tend to be kind of default to because we live on Earth, basically, and that's how we build things. Tend to build things. Not everybody does. So I would think start thinking more rounded curves. Um, again, for very practical reasons, because you don't necessarily need a down. Um, and again, they're going to be easier to pressurize. So those are some just kind of basic things that I would suggest if you're trying to create a realistic environment in science fiction. Consider what things would, how things would be used and how utilitarian they are in zero G. Honestly, just look at pictures of the International Space Station. That should give you a good starting point. Um, and then the other thing I wanted to mention here is how large these corridors are. If you've got a lot of space in, say, a corridor, remember you're going to have to put atmosphere in it, assuming your ship is pressurized. Um, and atmosphere is going to be weight. This is something you've got to maintain. So if you can do anything to limit the amount of atmosphere that you would need, the amount of air that you would need to, say, pressurize the hallway, that's probably going to be sort of a practical a thing that people that are trying to make highly efficient spaceships are going to think about. So if you've got a minor maintenance passageway, for example, that doesn't get a lot of use, do you really need it to be 5 feet wide? I mean, if it's just going from one place to another, I mean, really, you only need it to be wide enough to have a person be able to get through it, right? Um, Now, if it's a major hallway, consider how wide does that need to be? Uh, if it doesn't have to have equipment mounted on the walls or anything like that, you don't necessarily need to have these gigantically wide hallways. I mean, even the ones that we're used to on say Earth, like the one behind me, um, might be something that you wouldn't need to make that large on a spaceship, for example. And this is especially true if you're using the tech like I do in Regnum Humanitas, where the crew actually spends most of their time asleep, so they don't need to be, going through the ship during the voyage because they're in cryo sleep. So in that case, you don't necessarily need to have these wide, large corridors or passageways because they're not going to get a lot of use, and that's just going to be a waste of air, resources to maintain this atmosphere, and honestly, the materials to make it, right? So again, space is going to be a real, weight is going to be a real consideration in this environment. So that's another thing to think about. Do you need to have wide hallways? And if so, why? And then the last thing I want to talk about here is the whole concept of how you get around in the spaceship. How's the crew going to get around it? Um, and one of and I'm the example I'm going to use of this thing is an elevator. Do you necessarily need to have an elevator in a spaceship? Again, I think it would depend. I mean, if you're in using tech that's got pretty strong spin gravity, maybe, that's the same reason why we need them on Earth, so that you can, you know, quickly and efficiently transport, equipment and personnel between levels of your spaceship. But if you're in zero gravity, do you necessarily need one? And I would actually submit this that you don't necessarily need it. Say if the crew needs to get around, I mean, you could do something as easily low tech as just putting like say pull straps along the walls. These would be like things you have in say subway cars, for example. It's just a strap that's attached to the wall that a person can grab and sort of use to pull themselves along the hallway because they're in zero G, right? Um, but I'm actually going to throw out this idea that I've been kicking around in the Regnum Humanitas universe is the idea of a zip line as as opposed to using an elevator, for example. What I mean by this is just it's a very simple powered pulley system that you mount, say, along one wall or two walls, or heck, you could put them on each wall if you want to, or equidistantly space them around your cylindrical hallway. And this is basically something that just has a real simple, say, electric motor, and it's a constantly rotating line. So if you're a crew member that needs to get, say, from point A to point B, um, and let's say you don't want to just push off of one wall and soar down to the other end for whatever reason, you can just grab onto this constantly moving pulley system and it pulls you down there fairly easily and efficiently. I would say it'd probably be even more useful to transport large, or cargo or anything that's kind of large and awkward that might be a little difficult to maneuver in zero G. In this thing, you can maybe just hook this thing onto the zip line and it pulls it to where you need it, unhook it, hook it onto the next zip line if you need it, etc. And relatively low tech, it doesn't take a lot of maintenance. It's zero G, so you would need to have it to be strong enough to say overcome mass, but it doesn't necessarily need to have a high horsepower engine on it to move heavy material from point A to point B. Something that you could move in between levels, say in what you would usually call, maybe be thinking of as an elevator shaft. And it seems to me that it's a lot more efficient system, especially if you've got sort of a larger space station or spaceship that's operating in a zero G environment. So consider that. And the last thing I want to do is talk about airlocks. Everybody know, I mean, standard airlocks, between the vacuum and the interior of the spaceship, I think everybody's fairly familiar with that. Again, you can look at the International Space Station if you want to see how those work. Um, but think about including, say, interior airlocks. And I don't necessarily mean like the ones that you're doing on the exterior of the station, but more like an emergency bulkhead. And I think this I don't think this is a revolutionary concept. I think a lot of times people do realize that, yeah, we need to have, just like ships in the ocean, you need to have like interior bulkheads that would actually, if one section gets flooded or depressurized, you could seal it to to prevent the entire ship or space station from being depressurized. Um, so you might actually want to consider breaking your spaceship or space station up into smaller chunks. Um, and this is something that made, like in say 2001 Space Odyssey, when you're looking at that, the gravity wheel or this flywheel where they have pressurized thing, the whole area is open. And I'm like, that doesn't seem safe to me. I would say that, break it up a little bit and consider doing that. If you have these wide open spaces in your spaceship, consider, is that going to be a safety issue? If that space gets depressurized, is that going to cause major issues to the functionality of the space station or spaceship? Um, do you need large spaces in a spaceship or space station? Um, I think we would think maybe yes, just for psychological reasons. But again, remember, if somebody's used to, say for example, submariners on Earth, um, do they get used to that kind of claustrophobic environment? Where you've got everything's pressurized, everything's very, uh, kind of uh, built in these discrete chunks to prevent like the entire submarine from getting depressurized if you have damage in one section, for example, or getting flooded if you have damage in one section, for example. So consider that. So, and then consider how this flywheel thing, for example, how you're going to actually get between sections. And I would, um, how are you going to be able to travel between them? If again these interior bulkheads are open because you're not in danger of being depressurized. So let me just paint a picture of what I was thinking before. Um, for a standard spaceship in a Regnum Humanitas. Uh, and the first thing that I would say is it would be very claustrophobic to our current senses. Again, this is done to save weight because you don't want to have large corridors, for example, if you don't need them, and a way of it kind of minimizing the load on your life support system, so you don't have as much air to maintain and refresh. Um, they'd all be cylindrical again because these are in zero G environments, so you don't necessarily need to have standard corridors like we're used to. And you'd have the standard depressurization emergency bulkheads throughout the ship. So each compartment would be rather small as it could be, and still fulfill the function for which it's needed. So, for example, say an engine compartment might be larger than, say, a storage compartment, just because you need to have the engines in one area for maintenance or whatever. Getting around in the ship would either be by the pull straps, which are basically stuck all over the place, uh, and wherever people think they might be needed, equidistantly, or around the perimeter of the corridors. And for high traffic areas, you would have this zip line system that I was talking about, or places where you would need to say move large amounts of cargo, say to get into a storage a cargo bay or something. Um, and each compartment would have a zip line system, and then it would stop, and then you would basically between the compartments, that's where you would actually have to transfer to another zip line. So that would be kind of a design uh, uh, consideration when they were designing these ships in Regnum Humanitas. You don't necessarily need a zip line systems for places that are primarily going to be moving, say, people, but you would in a high traffic area or maybe where you'd have to move cargo, for example. Um, and in this system, there's really, control panels or consoles, chairs, tables, all that stuff, all the furnishings are designed to work in a zero G environment. So they actually would sort of dot the perimeter wherever there's room for them. And again, and everything would be as compact as possible to save on weight uh, when you're building the ship. So that's kind of what I envisioned. I mean, if you have other ideas on how this works, or if you think I'm totally off the rails with this, feel free to put something in the comments. But I'm going to close up just by saying, consider this. Consider how the interior of a ship would look, how the crew would get around, how a ship that's designed to work in the low gravity environment or zero G environment, uh, might look. Um, and also, because you're going to have the spaceships specifically are going to have to deal with acceleration. So it's not going to be a zero G environment. So consider the kind of trade-offs that you would need if you were um, to design a ship or a spaceship or a space station. Okay. And that's pretty much all I had. So you guys have a good day and um, be creative. Put a little thought into the interior of your spaceships when you're designing. All right. And have a good day.